Now in this experiment, we'll work on Kali Linux and set up a clean forensic workspace under forensic1 underscore experiment folder with subfolders for images, mounts, and exports. We'll pull a public digital corpora evidence file, the NPS 2009 Casper RW Gen 0 E01, which is compressed in case image of an Ubuntu Live USB persistent volume. Next, we'll install and verify ewf-tools, then use ewf-info to read acquisition, metadata, disk geometry, and the MD5 hash. So we know that what we are examining. After that, we'll mount the E01 read-only with EWF mount, which exposes a raw EWF1 device we can analyze without altering the original container. What will be demonstrated? So we'll be trying to explore what is inside the image, and we'll use the Sleuth Kit fstat for file system details, fls to list directories including orphaned and deleted entries, and istat to inspect inode metadata. So you can see how to move from a sealed E01 container down to file system and inode level evidence. Let's create experiment space first. So inside this, I'll create multiple folders. Now I've created multiple folders for this experimentation. So forensics 1 underscore experiment is my main folder. So here images folder is for storing the original evidence, original image. And the mount folder in E01, there will be E01 container which will be changed to raw view. And the fs file will be from the raw view, will be able to browse the file system. And the export folder will be where you will save out the extracted file, and notes where you can save your notes if required. The next step is go to the Digital Corpora website and download the image. So there are various images available. Now this time we'll be downloading the Casper image. So in Casper we have different images. So let's download the first one. So this image I'll be put I'll put in my images folder, and from command prompt I can verify the image as well. We have already seen the folder, but if you are interested, see from the command prompt, so you can see the details of your image as well. For this experiment we require different tools, so let's verify whether the tools are existing in my system or not. The first tool I required is ewinfo. So it's ew info. So ew info is not present. So if these tools are not present, you can install it. Kernel is updated. Now let's install the tools. Let's verify the required tools. The first tool is ewf-info and second ewf-mount. Next is mount and last one is f-user mount. So all tools, required tools are available on my system now. To perform these experiments, let's set some variable using export. The first variable set is image. So my image is available in forensic 1 experiments images. So this is my image. The next variable I want to set is for the output. So out variable. The output will be in export folder. So I want to save with the date. So I have created my required variables. Now I want to inspect the metadata for the image which I have downloaded from the Digital Corpora and using ewf-info. I want to get the metadata. So I will give my image location. My image location is in the image variable and I want to fetch the metadata information. And where I want to store this information, I want to store the information in the output folder, and in this I can create some file which will be having the metadata information. And metadata information is collected using EWF info folder. So I'm writing that um, writing with the same name. So it will save the metadata information in this file. So you can see it has displayed me the information. The same information will be stored in the text file as well. So this is the metadata information. So I can see the file as well. So uh, the image related information will be stored in using ls will be stored in a different text file. So the both files has been created. Now you can see the information stored in this file. So whatever it was displayed on the prompt on the terminal, so it's showing the same information as here as well. So the second file is also having the location. So about this image, we have collected the metadata, and the metadata information is in this file. If you want, you can check the integrity of this image as well. So let's check the integrity. So using, to check the integrity, we will use ewf verify tool, and the image location whose integrity we want to check. So MD hash value is what is stored in the disk is this, and what is recalculated is this. So both are same. So that means the file has not been modified. So no modification has been done. Whatever we have downloaded, we are using the same file. So this is just to verify the integrity. The same output you can observe from the text file as well. So whatever was displayed on the terminal, the same information is available here. So you can see here MD5 the hash values. Now let's understand the metadata. So our metadata information is stored in this file. So the first line ewf info, this line tells the version of ewf info tool which we run. So this is the version number only. Then the acquired information is, first one is acquisition date. So acquisition date is when the forensic image was created. So it was created on Monday, December 19 at time 13:06:22 and in 2011. So at that time, it's showing the system date next. So system date is this one. So system date is same as the acquisition date. So system date just represent the clock on the image machine at that time. So operating system use. So this image was done on the Mac OS. So Darwin means Mac OS kernel, and software version use is the version of the image EWF software and it was the version which was developed in 2011. So this is the year and date and month. So when the software was developed, that software was used. So and then it is E01 is not password protected. So not available means it's not password protected. Now the next part is EWF information, and in EWF information, the first thing is the file format. So file format value is encase 6, which is a classical encase E01 style container. And next one is sector per chunk is 64. So that means data stored in this image is in chunk of 64 sector, and error granularity is also 64. So error granularity represent how read errors are recorded. So chunk size is related to chunk size, and compression method is deflate. So that means contents in disk are compressed and is creating a smaller file on disk. And then is the compression level is best compression. So it's a strong compression. So it's a strong compression which give a slower image creation or open and indication of the smaller size. So if you go to the Digital Corpora, so here you can see the file size which we downloaded was MB. So it's compared to other images is having a smaller size. Um, and then is the identifier. So this is identifier. So this identifier is useful to uniquely identify for this evidence set. So if you have multiple parts, like our image was E01, so there are other parts also. Like our image was Gen 0 E01. There are Zen 1, Zen 2, Zen 3. There are multiple part of the disk available. So for this Gen 0, um, it's a can be identified from the set identifier. Now next is the media information. So the first one is the media type. So it is a fixed disk type. So what is a fixed disk? So fixed disk means that the evidence is treated as a non-removable hard disk. That means it would be an internal HDD SSD style storage, not a floppy CD or removable device in the image metadata. So next is a physical. So is a physical disk. So this factor also confirm this value. Yes, means it's presented as a physical disk or volume image. So bytes per sector, which is 512, which is standard sector size, and number of sectors. So this figure shows the number of sectors. And then is the media size. So if you multiply this figure with 512, you will get this number, which is indication that the media size is 600 MB size. And then is the MD hash value. So this is the MD hash or the integrity information or the hash value for this disk. Now what we have in the image folder is the E01 folder, E01 image. Now what we want is we want to change it to a raw virtual device. Now what is the purpose of this is an E01 extension is a forensic container which is compressed, and we can get the metadata and the hash values. So tool cannot always treat the file like a normal disk. So if you use the tool EWF mount, this tool will open the E01 extension file, which is read-only style file, and exposes a fake raw disk view under a mount folder. So what we input is we'll input the encase E01 extension file, and what we'll get an output, we'll get a raw virtual drive EWF1 that look like a plain disk or a volume. Now in this experimentation, we will get our E01 as it is. So it will not change. So let's open this command prompt. Now here we will use ewf mount. Our image is in the image variable, and I want to mount in the E01 folder, and let's see what we get. So we get ewf1 folder in this. If we want, we can save this information. So we are saving our information in our output folder only. It's e mount information. So information is stored there. So we have ewf1, which is a raw virtual block or file view of the disk volume. So now we want to set the location for this. So we'll create a variable. That's the variable name is raw, and we want to save this information, I mean the folder location, in this variable. So what we can see is so it's having this folder location. So raw is having this information, and this information also we can save in our output folder. Now let's see the raw image. This is, I mean, inside the image folder we have E01 file image. So we mounted in E01. So we have the raw image in a form of EWF1. Now I want to discover the partition for this or file system layout. No, whether there is a partition disk or a whole file system image. This we need to check. For this, we will use the Sleuth Kit tool, MMLS tool, for this purpose. So let's use this tool. So we'll use the MMLS tool, and it's showing the no output. When it shows the no useful partition table or no output, that means the most probably it would be one file system from sector 0. So the raw view is probably one file from sector 0, common for volume only or Casper or like E01 images. So what we'll do next is we need to confirm the file system at the start of the raw image. So we'll set some variables. Let's set export offset sector is equal to 0, and then another variable export offset bytes is equal to 0, and then confirm that now we have this information. So what this information represent? So we use the tool like ewf info earlier, so which shows about the E01 package. So it's acquired 2011 600 MB MD5 hash value. Now we have used fsstat here. So fsstat is about the ext3 file system inside it, which tell about the type, volume ID, and the last write. So um, what we get is an ext3 type of uh, the image with offset of 0. So file system type is ext3, so which is a Linux ext3 file system, general matched Linux Ubuntu style volume. And volume name is blank, which means that no volume label was set, which is normal. So blank is normal, and volume ID is given. So this is the volume ID, which is unique ID for this ext file system. So it's like a fingerprint. So last written at, so it's the time is given when the last time something was written to this file system, and last time checked. So the time is given when the last time FSCK style check was recorded. Last mounted is empty. So this means that no last mount path stored. Now let's see the root directory listing. So we have our raw disk in the raw variable. So we'll use -o and starting from 0, the raw folder. So it shows uh, two things. The first is dd. So dd here is means it's a directory, and 11 is the L-node number of the lost and found folder. So lost and found is a normal ext recovery directory, often nearly empty. This one, and then VV is there. So VV is the virtual Sleuth Kit entry. So it's not a real on disk folder. So orphan files is there. So orphan file is a TSK bucket for orphan metadata, unlinked contents. And then there is a number called 38401, which is a virtual address TSK uses for that view. So what we have learned is the TSK only shows the lost and found plus virtual orphan. So volume is very empty, so a sparse root listing is expected here. We can get the file system information using fsstat. So again, we'll be using -o and 0 starting from 0, and for the raw image. So we get some data here. So what information we are getting is of the file system type. So it's ext3 file system type image. So it's having, it means a Linux ext3. So volume ID, we get the volume ID. So it's a unique file system ID. And last written checked, uh, last time written, last time checked. This information we get using MMLS also. So the last mounted edge is also it's given here. So source operating system is the Linux one. So it's showing the Linux operating system is having a dynamic structure, and general inode value is 8. So it means that the ext general lives at inode 8, and feature is general directory image large file normal ext3 capabilities. Here you can see the inode is ranging from 1 to 38401. So an inode is the file system's index node. It stores the metadata record for one file or a directory. So it stored the type, size, permissions, honor, timestamp, pointers. So these values are stored in. So here you can get the details. The inode values from 1 to 38401 shows a possible is a file directory slots. So root directory is usually 2, like it's a standard ext root inode, and free node is 38389. That means it's almost all free. So if you subtract 38401 from 38389, it becomes 12 inodes. So very few files or directories are present in this. The next part is the content information. So here the block range from 0 to 153599. So that means there are 153600 blocks are there. So block size is 4096. That means it's a 4 KB uh, per block. So there is a 4 KB per block data. And free blocks are 14696. That means mostly empty spaces are there. The next one is the block group information. So as you can see, the number of block groups are 5. So there are 5 groups starting from group 0, group 1, group 2, group 3, and group 4. So there are 5 groups present, and each each ext split the disk into 5 groups, and each has the bitmaps, which block nodes are free, inode tables, data blocks, later informations. So here shows that there are 97% to 100% free spaces are there. Now if you know the index value, file system index value, you can use is stat, like for this. For the raw image, if I set the index value 11, I want to see the metadata. It shows the information. So what information shows is inode value is 11. So which is the metadata address you asked for. So allocated means it's a yes. This means this inode is in use, and group is 0. So group is 0. Here the group is 0, which means it is a lives in a ext block group 0. And uid group uid guid is 0/0, which means it's owned by the root. And the mode is drwx, which means d is a directly only owner, means which is root can read, write, or enter into it. And the size is 16 KB, and number of link is 2. So number of link is 2 means it's typically for a directory. That means for dot and the parent linking accounting. If I want to read, if you want to read a directory, I can use FLS, and I can give the index value. So here there is no output. So no output means the lowest and found directory is empty. Next we can confirm that index 11 shows it's still a directory. So what we can use is istat. We can use So it's showing the information. So it's a directory. D stand for directory. So it's a directory only. So we can now search whether there is any file existing or not. We can use FLS only. So it's a directory. So lost and found 11 is index 11 is a directory only. So it's a lost and found directory. So that means the lost and found is 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 uh, uh, is empty. It's a directory and it is empty. So next is we can search whether there is any deleted entries or not. So it's showing 0. That means there is no um, deleted entries. So next we can see whether there are any raw files, regular files are existing or not. It's already empty, so no output is expected. So what the result shows is, so this option shows that there are only lost and found and orphan files existing, so no other directory files in the tree. And minus D option, there's no output, which means no deleted entries in TSK can list. And then with RR, this options also shows that the 0 regular files are allocated in this. So at this location also we are not able to find anything. So if we want some output, we have to use a different image. Like we get the information for the lost and found folder, we can get the information about the root directory, the metadata as well. So for this, what we need to use is istat only. So instead of 11, which is the index value for the lost and found, we'll use the 2, which is for the root. So we get the metadata related to uh, the root directory.